All right, today is 1-6. It is the last section that's going to get covered on your test, which is next Tuesday, which will cover 1-1 to 1-6, okay? And it is end behavior. So if you remember from Algebra 2, end behavior is what happens at the ends of my graph, meaning all the way left and all the way right. In Algebra 2, we use words like falls left, rises right, rises left, falls right, falls left, falls right, rises right, rises left, rises right. Those are your four options, okay? And that's the language that we used. When we get into the AP language, it changes a little bit, okay? So this is the language we used to use. This is going to give you a good depiction of what it looks like. You can still think this way, okay? But when we answer these questions on end behavior, they will be very different. The notation is different, okay? So if your degree, remember we're talking highest exponent, so we'll always either put this in order or we will look for the highest exponent. That is your degree. If it is odd, then the ends have opposite behavior. One goes up and one goes down. If it's odd and the leading coefficient is positive, then it falls left and it rises right. So the image of it, again, the arrows on the left point down, the arrows on the right point up.
I never got the notes.
So, all right, then it could say, then like if your leading coefficient is negative, the graph rises left and falls right. So the arrows would point up to the left and down to the right. So when you see this in notation, it's a x to the n. The a is the leading coefficient, the n is the degree. I mean, it's not really a formula. You're going to look at, you're just looking for your term. Okay. Yeah, but in notation, it's going to refer to it as a. That's what I mean. Okay. Then even, if the exponent is even, or that highest exponent, the degree is even, and the a is positive, then both ends point up. Think about like your typical parabola. Both of them would point up. See how this would have been helpful yesterday? Yeah. All right. Then if a is negative, both sides point down. We don't know what's happening in between, okay? But at least we know the ending behavior.
Would we have to do like yesterday's way, or could we just...
No, now you could do this.
Oh, so you don't have to plug in?
You don't have to plug in points anymore. Yeah, you might have to plug in if you're unsure, but if you understand and grasp the bouncing and the crosses through, that should be enough information to determine your intervals above and below.
Or you still have to check out the other way because this is how you like the ends and you need to like...
Right, but if it crosses through, it means it crosses through. If it bounces, it bounces. Then you would know from there which the direction takes. Yeah. You would just know. Guys, this is a really good question. So if I had x minus, you said x minus 4. Let's say I have x minus 4 to the 6 and you don't want to FOIL that out. You only need from there your leading term. Your leading term would be x times x times x times x 6 times. So it's x to the 6th.
And if you had to multiply by something else, like if it's not just that.
So let's say it's x to the 6th, like that. And then let's say it's 2x minus 3. This produces, oh, I'm so sorry. I meant to put it by the thing. It's there. 6 would come from the first one, and then this leading coefficient is just 2x. So it would be 2x to the 7th for your leading coefficient. If it was negative 2x, it would be a negative 2x, right? So you don't have to FOIL them all the way out to find your coefficients. Yep, just look at the one on the front one.
So
If it was like 2x to the 6th, then the 2 would be raised to the 6th, which I don't need that value. I just need to know it's positive. Does that make sense? Okay. Was that your question?
yeah, like if we had like an x multiplied by x, it would just count, like add the exponents.
Yep. All right, this is how the AP notation works. So it is still the same concept. If it is even and positive, okay, wait, I don't want you to take a picture of it. Oh, unless you don't. So there's two ways to write it, okay? One is on the left, and think about what this is saying. If it's even and positive, they're both pointing up. So as my x values are approaching positive infinity, which means as they go to the right, my y values are approaching positive infinity, which means they go up. As the x values are approaching negative infinity, that means as it goes to the left, the y values are approaching positive infinity, which means they go up. in limit notation, which is what that next thing is, and that's what the AP will use, so that is how you will be tested. It says the limit of my graph. Now the limit of my graph is what's the end of my graph, right? Where does my graph stop? Where's the limit of it? And if there are arrows on both sides, there is no stopping it. So as my x approaches, let me do it in the same colors. As my x approaches, no, I was right, dang it, negative infinity, which means as it goes to the left, what's happening to the y, which is now p of x, because that's the same thing, it's going to positive infinity. What's happening when my x approaches positive infinity, which means it's going to the right, the y is approaching positive infinity, which means it's going up. So the notation changes. It is limit x to the negative infinity and limit x to the positive infinity. And then after that is the direction it goes. So if you look at all of them, they all start this way. Limit x to negative infinity, limit x to positive infinity. And what that means is as I go to the left or as I go to the right, after that is what's happening with the arrows. The p of x is going to positive infinity, means it's rising. And that's happening for both of these. Yep.
Why is the green arrow pointing to the left and the X pointing to the right?
So this is to negative infinity. Is that what you mean? This one?
No, it's the one above. The green arrow is going to the left.
So it means it's going to negative infinity, which means we're talking about what's happening on this side. As the x is approaching negative infinity. Is that what you mean? Yeah. All right, so now this is, focus people. This is even and negative, okay? So in plain speak, what does even and negative do? That's not plain speak. End behavior. Sorry, end behavior. Both are going down, yes? So as we're approaching negative infinity, how do we say down? How do we say down in our limit notation?
Negative infinity as y.
As we are approaching negative infinity for the x, the y, right, which is the p of x or whatever the actual function name is approaching negative infinity. So as the limit of, or the limit is of x going to negative infinity, the p of x is also going to negative infinity. So as I go left, I'm going down. Yes.
Are they switched up because that x has negative infinity and that other one has positive?
This goes with this. The order doesn't matter because it's not going to always be in the same order. Is that what you mean? Yeah. And then as the limit is approaching positive infinity, or as the graph is approaching positive infinity, what's happening to it? It is approaching negative infinity as well. So as this is going right, this is still going down. Yeah.
It's going to give you like a graph or an equation.
Correct. So we're going to learn how to do this from an equation or a graph.
So like it's not just going to tell you like even and negative.
No, it'll give you the equation. Yeah. All right, now we go odd and positive. So if my exponent is odd, but the leading coefficient is positive, it again in like regular words, what would that be? Odd but positive. Falls left, rises right. So as I move towards the left, so this one goes with this one. I apologize, that's confusing. As I move towards negative infinity, which means as I move left, my graph is pointing down, which means the f of x or p of x, whatever it is going to negative infinity. As it's going to the right, which means as my x is approaching positive infinity, the y is getting bigger, which means it is approaching positive infinity. Yeah.
And you always start with x to the negative.
I mean, it could just ask for one part of it, but normally if it gives both, it will say that. This is multiple choice on your test
Okay.
because there's only 4 options. Either they're both going up, they're both going down, it's up left, down right, or up or down left, up right. It's one of those 4 options. Yeah.
Why did you put the arrows down, one down, one up?
Because if it's odd and positive, it is falling left and rising right.
Oh, because if it's odd, then it's like
They're opposite. One goes up, one goes down. If it's positive, that means the one on the left is going down, the one on the right is going up.
if it's even, they would both go up.
Correct. Yep. Yep.
It's not one or the other, you have to write both of them.
Correct. It's going to ask the end behavior, and the end behavior is both of those things. What's happening as x is approaching negative infinity, and what's happening as x is approaching positive infinity. You have to have both. All right, last one, odd and negative. So if it's odd and negative, it is rising left and falling right. Rising left means as x approaches negative infinity, the y is approaching infinity. So it would be limit x arrow negative infinity, p of x is equal to positive infinity. So those two go together. And then as the x is approaching positive infinity, meaning as it goes to the right, my y is approaching negative infinity, or p of x equals negative infinity.
Do you care about the order that we have them in?
No, you will usually go negative infinity first. It will usually go in this order, okay? But on your test, it's multiple choice. So you'll spot it.
Wait, hold on. You're answering with like one or the other.
You're answering, this would be your answer on your test. It means the same as this, and you'll see that notation used, but you got the answer, like on your multiple choice will be like this. On all the practice tests we've seen AP, like this.
And you don't care which one's on top? Or on top?
No, it will be multiple choice. For your homework, I don't care which order it is. I would say it's multiple choice, and the multiple choice I led with negative infinity for x, so maybe just get in that pattern. But it doesn't mean it's wrong if it's switched. This one is not. There's only 4 options, so I gave you the 4 options. Yeah. All right, so let's do it from an equation. I'm going to do the first 2 with you, and then you're going to do the last 2 by yourself. Okay, first of all, I need to look for what? Of all those terms, which one's the most important? Not which is the leading one? The one with the highest exponent, not necessarily first in order, okay? That's how they will trick you. So I'm going to look for the one that is the highest exponent. For A, it is the first one. The exponent is even or odd, and the front number is negative, which means rises left, falls right, yes? So as the limit approaches, or x approaches negative infinity, f of x is approaching what? Positive infinity. Good. As the x is approaching positive infinity, f of x is approaching negative infinity. Yep.
So you have to put both of them?
Yes.
Not just one?
It is end behavior, both sides. All right, go to B. What's my leading term? Negative 3x to the 4th. This is even and negative. So that means both. Falls left and falls right. Both are down. So as x approaches negative infinity, f of x is approaching negative infinity. And as x is approaching positive infinity, f of x is negative infinity. All right, so C, what's my leading term? X to the 3rd, which is odd and positive, which means what in normal words? Falls left, rises right. So the limit as x approaches negative infinity, f of x would be negative infinity. And the limit x as it approaches positive infinity, f of x would be positive infinity. And the last one, the leading term is positive 3x to the 4th, which means both up. So as x approaches negative infinity, f of x approaches positive infinity. And as x approaches positive infinity, f of x approaches positive infinity. Easy stuff, right? If you know what you're doing and you don't get caught in the always grabbing the first term, I would say those are the mistakes people make, okay? All right, then it says sketch a graph of the polynomial function that could match this statement. So all we're focusing on first is the end behavior, and then we're going to kind of guess what happens in between. We don't really know, okay? Yeah.
Even though there's like no limit since it goes to like both infinity to
So we say the limit is infinity. Yeah.
still write it out like
Yeah. All right, so if you look at A, it says the limit as x. Oh, let me zoom out so you can get the. Or do you want them close? Okay, sorry. Just remind me. Okay, as x approaches negative infinity, p of x equals negative infinity. What does that mean?
Following the negatives.
It means it points down on the left, yes. And as the limit approaches, or as x approaches positive infinity, it goes to negative infinity. What does that mean? It's also down. Then you can do anything you want in between there. You can make it a parabola. You can make it like squiggle. I don't care. Okay? That's why it says what could match. Okay? Obviously, if you had multiple choice, only one of them would have both arrows pointing down. Okay? But if you were just drawing this, like in the homework tonight, you're just drawing it, doesn't have to perfectly match what the graph looks like. Okay? All right, B. As x is approaching negative infinity, p of x is approaching negative infinity, which means falls left. And as x approaches positive infinity, p of x is equal to positive infinity, which means up. So I could literally go up, come back down again. I could just do this, okay? Anything like that, in which the left side falls and the right side rises. No lines. These are polynomials, so they have to have some sort of curve. That was so easy. I love to hear that, right? That's it. You're done.
Yes.
Okay. This first question, I want you to think about how now end behavior helps you with this, okay? So it says the polynomial function is given by p of x equals 3x times x minus, or x plus 1 times x minus a, okay? Having known that, look at your exponent, right? So having known about end behavior this time, if this is x to the first, and then this is x to the second, because that, if I did x plus 1 times x plus 1, and then this is x to the first, I wrote all over this, but this would have been x to the second times x to the first. So my exponent would be 4, which means it's even, yes? And we talked about that on an even, like we talked about it briefly yesterday, but now we for sure understand that if it's even, they're both going up or they're both going down. If the leading coefficient, which is 3, is positive, now I know they're both pointing up. So having known that, it literally rules out 1 and 2. The arrows have to point up, okay? And it goes to C and D. Then it says that x plus 2 squared. If there are two negative ones, what happens at negative 1? It bounces, okay? And then there's 1, 0 at 0, but this is where, like, we literally have had this discussion because I saw the 1 bounce at negative 1 and I picked it. The question is, and I don't even know the answer to this yet, so I'm going to do some more deep diving. This says x would be 0 and it would occur once, which would mean it should pass through. Unless this was also 0, right? Then it could bounce off of it. Yeah.
By that logic, couldn't C also be the correct answer if it was negative 1 again?
Right, which is what we were just talking about. I don't know why we're saying that can only be 0. Why couldn't it also be positive 1? Yeah. So this question to me, like, we'll spend some more time on it. For me, I saw the negative 1. It bounced, made sense, circled it, done. Okay? But as we start to nitpick a little bit more, I think it gets more confusing. Huh? Yeah, right. I'm sure there's an explanation. Just haven't quite figured it out. So I obviously, the prior knowledge of end behavior is what led me to that. But we did talk about in 1.4 that if it's an even, that there's either a max or a min and there can't be both. Yeah, no, that's still it. Yeah.
The only,
Yep.
they talk about real numbers, just,
All right, 2 was the differences in the table, right? It took to get to the 4th one before they were all the same, which that's 4. Yeah. Yeah. Okay. I hit the wrong button. 3, okay, so 3 said, which of the following could define P of X? From my graph, I've got a 0 at negative 3 and a 0 at 4. So at negative 3, it would look like this. At 4, it would look like this, and it bounced. at 4, which means this had to be an even exponent, okay? If you look through them, there was only one in which x minus 4 was raised to an even power. And then there with also x plus 3 is your other one. There was only one with x minus 3 raised to an even power. It could have been 2, it could have been 4, it could have been 6, so it didn't have to be squared, okay? But at least, and the same thing with x plus 3. It could have been x plus 3 to the third, x plus 3 to the fifth, because it had to be an odd power, but it worked.
Why is it divided by 12?
It just says what could it be, so it literally could have had anything down there.
Oh, so as long as like the parentheses and like the powers are.
Yep, and it was a constant in the bottom. If there's not a constant, it changes it. It gives you an asymptote. That would change it. It would be like a 1/12. Correct. All right, 4 says the function q is a polynomial degree of 3. If q of 5 equals 0, which of the following must be true? Okay. First of all, A says q of negative 5 would also be 0. That would happen if this was an even function. So if it said it was an even function, that's my right answer. B, it has 2 complex zeros. We don't know that. We know this is one of the zeros, but it doesn't say it's the only one. If it had said it was the only one, now I know the other 2 are complex, okay? C, it can be written as the expression of x minus 5. That's for sure, because if 5 is a 0, then x minus 5 is one of my factors. And then the second part, where what's left over, it has a degree of 2, which aligns with the fact that this is a degree of 3. So one of them is 5, and there are 2 more. And then D doesn't make sense because you'd have a degree, I'm going to multiply of x minus 5 and then a degree of 4. All right, 5 says the leading term of the polynomial function is where a is a real number and is a positive integer. The factors include, and it gave you x minus 3, x minus I, x minus 2 plus I. Both of these are complex, which means they also would have the opposites as part of the roots. And if you literally just counted that, there was 5 zeros, which is the degree of 5. And then 6. I'll be honest, this one threw me too. The language in the first class, I even pulled it up and it was like, what? Okay, it says, first of all, the one says, which of the following conditions guarantees it's an even function? So we're looking at each of these and you're trying to see if the only possibility is that the exponents here would be even, right? That's what makes it an even function. So k being 0 means that this is gone. It could be an even function if j was also even, but it doesn't say that, which means j might also be odd. And so that one doesn't work. J plus k is even. If I took my exponents and I said 2 plus 4, that's 6. But what if my exponents are 3 and 3? The sum is also even, but the actual exponents are not, right? J times k is even, so something like 2 times 3 would also give me an even product, but the individuals are not both even. The only way to get something that was even is to take j. Well, first of all, k has to be even. So if k is even, if it's 2, 4, 6, 8, 10, 22, whatever it is, and you double it every single time, you get an even number. That's the only one that would guarantee even exponents for both. Does that make sense? Yes? How many of you got 3 or more right on last night's homework, AP homework? Okay, good. Good, good, good.